All right, welcome back to the Celestial Wheel. I'm QMC Simpson, and we'll be getting into sunset by strip form today. All right, hopefully you watched the first video where it's just how do we find sunrise using the Nautical Almanac. It's basically the same math, just different times, all right? Like, same thing I did before. I put latitude, longitude in the DR. I explained how we got that DR in the first video. So basically, every time you take a fix, whether it's EP, celestial fix, visual fix, radar fix, composite fix, you would DR off of that. And that's the DR. You would DR out to the time that you would imagine would be sunrise or sunset, and you'll take that latitude, longitude, and you write it down there. It'll be using that, going into the Nautical Almanac. All right, same thing with sunrise. Circle sunset, got the latitude, longitude, got the time, or excuse me, we had the date. Go on step 3, we're going to bring down the longitude. Always label. Now in step 4, we're going to step back into the Nautical Almanac and bring out the differences between the two tabulated latitudes that our latitude falls in between. Just like before, the latitudes that we use is 35 and 40. You're going to find the difference between the two. It'll only be between 10, 5, and 10, or 10, 5, and 2. Increase or decreases as you get closer to the North Pole. We found the difference to be 5 degrees, so we're going to go ahead and write 5 degrees right there. Number 5, difference in time for tabulated latitudes. The same latitudes we just pulled from the Nautical Almanac, there's times associated with it. And we're going to pull those times and write them down. 1701 and 1709. And we're going to find the difference between those, which would be 8 minutes. Go ahead, write 8 minutes. Step number 6, the lat difference. The difference between the DR latitude and the base latitude, the latitude closest to the equator. So between these two, 36 lies in between them, and we're going to go off the one closest to the equator, which would be 35. It decreases down from the North Pole down to the equator all the way to 0, which would be the equator. So the difference between 3656.06 north and 35 is 1 degree, 56 minutes, 06 seconds. Now, just like with the video before, we're going to end up taking this equation right here in step number 7. But I want to take number 6 answer and convert it to one number. Take 06 divided by 60, add that total to 56, 56 decimal, whatever it is, divided by 60, and add that decimal to the 1 to get a whole number in degrees. And I end up getting 1 degree. And I end up getting 1.935 degrees. We did that to make the math easier, because it ended up having to convert it anyway. Follow this equation exactly how it's written. You have number 6 would be 1.935 divided by number 4, the 5. Let's go ahead and do that. Then you're going to take that answer that's in your calculator, and you're going to multiply it by 5. Step 5, which would be number 8 times 8. And we got 3.096. I'm just going to round that to 3 minutes. 2 more steps before we're done with latitude. We're going to get the time for step 8, time extracted from the Nautical Almanac referring to the base latitude. We use 35 because that's closest to the equator. We're going to take that 1709 and write it in there. Also, before going back to step 7 real quick, finding out if that 3 minutes is negative or positive, you want to look at this right here. 36 lies in between 35 and 40. As we increase going up, you can tell by the sun, or excuse me, the time is decreasing. You want your time to be in between 1701 and 1709. For this, it's telling me to subtract. I'm going to subtract 3 minutes from 1709, and I get 1706. Okay? We are done with latitude. We're going to be switching gears to longitude. Step 10 says take the longitude that we had from up there and bring it down here. Step number 11, we're going to find our standard meridian. You can follow this right here where you bring them up all the way to a whole number, 0.76 decimal, blah, 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 and divide that by 15, then multiply it by 15. Or I like to illustrate it. I draw 3 lines right here. I know it increases by 15 degrees as I'm going west. You can keep going all the way to 0 if you want it, but just for sake of time, I know all my time zones are by 15s. 0.76 lies right about here. And I know my closest standard meridian will be 0.75. Step number 12, we're going to find the difference between the standard meridian and the DR longitude in degrees, minutes, and seconds. So basically, subtract 0.75 from 0.76, you get 1 degree, 19 seconds. Same thing we did over here when we found the difference between the latitudes and our DR latitude. We're going to convert this to one number. We'll do 19 divided by 60, get a decimal, plus 19 for the minutes, divide by 60, and then plus 1 for that degree. And it goes up to 1.32 degrees. The decimal obviously keeps on going, I'm rounding up. We did that to make this math easier. We're going to convert arc to time. We're going to take this 1.32 degrees of arc and convert it to time. For 1 degree of arc is 4 minutes. So we're going to take that 1.32 and multiply it by 4. We get 5.2 minutes. I'm just going to round it to 5 minutes. Step 14, we're basically taking number 9 and bringing it down. All right, reverting back to 13, this would be a positive number because we have to add from our standard meridian to where we actually are. So 0.76 plus 5 minutes would be 17:11 zone time. But as I explained in the last video, we're in daylight savings. Between the months of April to November, we recognize +4 Quebec here in Norfolk. We don't revert back to +5 Romeo until November. Making this, we had +1 hour, 18:11 zone time. Like I said, it'll be in between probably 1809 to 1812, depending on how you rounded up everything. But it'll be the general time of where the sun will actually set. Hopefully this helps you with your strip forms. When you're starting to learn strip forms, don't rely solely on Stella. Stella is a great tool if you're trying to get the quick answer, but actually knowing what Stella is doing, by knowing how to do it yourself, it helps tremendously. And it's fairly easy as well. Simple math as well. All right, if you enjoyed this video, give it a like, consider subscribing, and join us on the next video when we talk about more in celestial navigation.